Sound is a fascinating phenomenon in physics, and understanding its properties helps explain how we hear and interact with the world around us. Longitudinal waves and sound. Sound travels as a type of wave called a longitudinal wave. In a longitudinal wave, the vibrations of the particles in the medium, like air, water, or solids, occur along the same direction as the wave itself. Imagine a slinky stretched out. If you push and pull one end of the slinky, the coils move back and forth in the direction you push and pull. This movement creates compressions, where particles are close together, and rarefactions, where particles are spread apart, and these are the fundamental aspects of how sound waves travel. Sound as a longitudinal pressure wave. When you make a sound, such as speaking or clapping, you create vibrations that disturb the surrounding air particles. These vibrations push and pull on the air particles, creating regions of high pressure, compressions, and low pressure, rarefactions. The wave of pressure changes travels through the air or other mediums, from the source to your ears, where you perceive it as sound. Reflection and absorption of sound. Just like light, sound can be reflected and absorbed. When sound waves hit a surface, some of the sound is reflected back, which is why you can hear echoes in large, empty spaces. Surfaces that are rough or soft, like carpets or curtains, absorb sound waves rather than reflecting them, which helps reduce noise levels. This absorption is why rooms with lots of soft materials tend to be quieter. Speed of sound. The speed at which sound travels depends on the medium it is passing through. Sound travels faster in solids than in liquids, and faster in liquids than in gases. This is because particles in solids are closer together and can transmit vibrations more quickly. For example, sound travels faster through metal than through air because the metal's particles are tightly packed and can transfer the vibrations more efficiently. Frequency and pitch. The frequency of a sound wave refers to how many vibrations occur per second, and it determines the pitch of the sound we hear. Higher frequency sounds have a higher pitch, like a whistle, while lower frequency sounds have a lower pitch, like a drum. The frequency is measured in hertz, with higher numbers corresponding to higher pitches. These concepts explain how sound waves travel, how they interact with different materials, and how we perceive different pitches. By understanding these principles, you can better appreciate the complex nature of sound and its role in our everyday lives.